Good afternoon, everyone. I'm David, and today our group will be examining AI-driven coding tools and their future potential in software engineering. Our key research question is, how are AI-driven coding tools transforming software development practices, and what potential do they hold for the future? Throughout this presentation, we'll analyze current technologies, evaluate their practical impact, and assess future directions. The significance of this topic extends beyond the mere productivity tools. Traditional software development has required extensive technical knowledge and training in specific programming languages. AI coding tools like ChatGPT are now bridging the gap between human intent and machine-readable code, potentially democratizing software creations for a wider audience. Our analysis is grounded in the recent academic research, including the paper ChatGPT for Higher Education and Professional Development, which examines how AI tools serve as partners rather than replacements in educational and professional settings. This research highlights three key benefits, such as enhancing learning by explaining complex coding concepts, providing research assistance to increase productivity, and helping developers detect and resolve errors in their code efficiently. As you can see, this is an AI assistant generating functional code from a simple natural language description, something that seemed impossible just a few years ago. This represents a fundamental shift in how software can be created. As we explore this topic, we will evaluate not only the benefits but also the limitations and ethical considerations these tools present. The research cautions against over-reliance on AI tools, emphasizing that they could complement human coding skills rather than just replace them. We'll discuss how these systems are evolving beyond simple code suggestions towards understanding broader project goals and performing comprehensive software testing. So now I'll hand over to Abel, who will explain the technical foundations behind these revolutionary tools.
Thank you, David. Hi, my name is Eva, and I'll now delve into the technical architecture and mechanism that power modern AI coding tools. Now, architecture and technology. At the core of AI coding assistants, like as we all know, ChatGPT, is the transformer architecture. And this neural network design, first introduced by Vasily et al. In their seminal 2017 paper named "Attention is All You Need," is published in the Proceedings of Neural Information Processing Systems, which has revolutionized natural language processing and code generation. Now, ChatGPT specifically uses a generative pre-trained transformer model built on the GPT 3.5 architecture by an OpenAI. According to a researcher named Brown in 2020, this architecture contains approximately 175 billion parameters, allowing the system to 1. Process context from up to 4,096 tokens simultaneously, and 2. Understand semantic relationships between natural language and code structures. Now, what distinguishes transformers from earlier recurrent neural networks is the self-attention mechanism, which enables parallel computation, and it also captures long-range dependencies in both natural language and code, according to a researcher named Kinnaid in 2020. Now, when we speak about training methodology, these AI coding tools undergo a sophisticated multi-stage training process. Now, one of them is called pre-training, and is when models ingest massive data sets of internet text and code repositories. For example, CodeBuild was trained on the 2.1 million BIMNOP data points and 6.4 million unimodal codes across 6 programming languages, according to a researcher named Feng in 2020. Now, fine-tuning is when the pre-trained model is specialized to using supervised learning on a paired examples of natural language descriptions and corresponding code implementation. Now, a researcher named Shen in 2021 demonstrated that this approach yielded a whopping 35% improvement in code generation quality compared to models without fine-tuning. Now, RLHF, which stands for Reinforcement Learning from Human Feedbacks, models like ChatGPT incorporate human evaluator ratings to refine outputs through a reward mechanism. A researcher also named Onyang in 2022 released an article about how it shows that RLHF significantly reduced harmful outputs, and it also improved healthiness. Now, the training data typically includes diverse programming languages, documentation, Stack Overflow discussions, and also GitHub repositories, creating a rich contextual understandings of both natural language and multiple programming paradigms. There are a few technical limitations that I'm about to discuss here, and One of them is contextual understandings, and while pattern recognition is strong, true comprehension of program logic remains limited. Current models achieve only around 54% accuracy on complex reasoning tasks requiring multiple logic steps, according to Lee et al., a researcher in 2022. And the second reason is hallucinations. Now studies show that around 17 to 24% of generated code contains logical errors or references to non-existent APIs, according to a researcher named Rahman et al. In 2023. And the third reason is that input size limitations. Now, most models have token limits between 2048 to 4096 tokens, which creates difficulties when processing comprehensive code bases. Now, in conclusion, these limitations represent significant gaps in current research, highlighting the continued need for human oversight in the development process. And I'll now hand over to Edwin, who will demonstrate practical applications of these AI coding tools in real-world development workflows. Thank you.
I find it very ironic that the industry that AI has the greatest potential to disrupt is the very industry it emerged from. As generative models such as GPT-3 and Copilot have given us the ability to generate code and entire programs or tools from a single prompt, the implications this poses for the tech industry will be vast, and I'm going to go over some of the current situational examples in which this technology is being used. In its current state, AI is most commonly seen in practical environments in the form of the AIDE, or the Artificial Intelligence-Driven Development Environment. These include things such as Microsoft Visual Studio IntelliSense, GitHub Copilot, and the current implementation of JetBrains PyCharm. These AIDEs can provide contextual prompts and helpful tips, as well as code snippets and even full sections of completed code in order to help users complete projects faster and more efficiently. These aids essentially act as if you had your own computer science expert next to you that could give you insight on the task you're completing and generate code for you on the fly that is specifically tailored to the project you're currently working on. As a matter of fact, it's been noted by many industry professionals and even been implemented in many workplaces that AIDEs can be a alternative towards traditional forms of pair programming. Pair programming being when two or more programmers program together to oversee and check each other's code. In this situation or scenario, pair programming is being used as the sort of mentor or other figure in the programming pair that can overview and oversee code being written and can debug it as it's being written. The use of AI-powered pair programming comes with pros and cons. AI-generated code is not often created to be error-proof or have any safety measures. It doesn't have any error checks, it doesn't have any input validation, for instance. And this is obviously undesirable when you're creating code to an industry standard. Another issue that comes up with AI pair programming is that novice programmers often tend to have an over-reliance on the AI for debugging issues. They also often place a heavy reliance on the AI for learning how to code. Instead of using it as a tool, they use it as almost as a crutch for their own shortcomings, which this can be said to be applicable to many situations for different programmers of different experience levels, but is more often seen in novice or entry-level programmers or junior programmers. They often accept AI-generated code without parsing it for issues, and this can lead to different issues down the stack or generate errors in the future. In addition to the AIDE, we also have access to large language models. One of the most prominent of these that I've been seeing a lot recently is Claude 3.7, and this has been garnering a lot of buzz and traction online in sort of the last week or so because it's been used with a single prompt. A user created a multiplayer game that runs in the browser in which users could log in and interact with this three-dimensional world where they could buy objects and sort of fly them around and talk to each other in a sort of global chat sort of system. And this was made in a single prompt and is still up, even though the person that created it had some doubts about the game's stability. It's still working to this very day. And various examples can be seen across the internet of Claude 3.7 being used to be doing some truly remarkable things in the field of sort of AI-generated game programming. From my own personal experience, one of the major downsides with AI development or with using AIDEs or with using these generative technologies to generate code for projects or for industrial purposes is that they rely so heavily on previously existing content that sometimes when you're doing something that's very particularly niche, using a framework that might not be widely known, using something that might not be widely documented, you can often see an AI struggle in these situations to generate something that's really to do contextually with your situation.
Thank you, Edwin, for illustrating those practical applications. I will now examine the future trajectory of AI coding tools and their broader implications for software engineering. Emerging research directions. There are three major trends shaping the future of AI coding tools. First one is multimodal code generation, where we'll be able to generate a program by voice command or use sketching in order to create a front-end code. Second trend is self-improving code models, where AI models will learn and improve from their own mistakes. AI assistants will be able to adapt to individual coding styles and, even better, will be able to debug its own code, fixing any issues before deployment. Third trend is specialized domain-specific coding assistants, where models will be trained for specific industries. For example, in finance, models will ensure code complies with strict financial regulations automatically, and in healthcare, they will generate HIP AA compliant software. Economic and workforce impacts. Traditional coding skills will become less critical, and developers will need to focus on problem decomposition, prompt engineering, and system architecture concepts. Security risks. AI can generate code quickly but doesn't always write secure code. Companies will need strong auditing processes to check AI-generated code for security flaws. Access and equity issues. High-powered AI tools require expensive computing resources, meaning big companies benefit more than small developers. The digital divide could widen, with smaller firms struggling to compete against companies that can afford cutting-edge AI tools. AI-powered development may become dominated by a handful of tech giants, limiting competition. Recommendations for the future. So, where do we go from here? Based on current research, here's what we as developers should focus on. Firstly is education reform. Universities should shift from syntax-heavy courses to AI-assisted software engineering. Prompt engineering should be taught alongside traditional programming. Ethics and responsible AI use should be part of every CS curriculum. Secondly is a balanced implementation. AI should be seen as an assistant, not a replacement for developers. Companies should implement human review processes for AI-generated code. And regular security audits will be necessary to catch AI-introduced vulnerabilities.
As software engineering students entering the industry during this transformative period, understanding the technology is very crucial. The ability to effectively collaborate with AI tools while maintaining awareness of their limitations is an essential skill, so we encourage anyone to explore these tools firsthand and contribute to the conversation about their responsible implementation.